All right, let's talk about linear attributes and word problems. I've got two graphs right here just to start out with examples. The first graph is talking about a savings account or money in savings account over a certain number of weeks. And the second graph is showing us money in our savings account over, again, time, certain number of weeks. But we can see in this graph right here, our money is increasing over time, and we can see in this graph our money is decreasing over time. Now, just like we have in previous videos, you can always find the slope of any sort of situation, or in this case, we would call this rate of change when we're talking about word problems, our rate of change, just by finding 2 points on our graph and counting our slope, or our rise over run. So don't forget that rate of change, slope, that is our m value in an equation, and that's just rise over run. For those of you that really like using algebraic expressions to solve problems, don't forget that the slope formula is just y2 minus y1 over x2 minus x1, okay? You can always just subtract your y values over your subtracted x values. So let's talk about what these points mean. The y-intercept in both of these problems, our y-intercept is called the initial value. It's our starting value. It's our initial value. Initial value. That's just how much we start with, okay? That's our starting amount. Obviously, we can tell, or hopefully we can tell, that the money here just continues to increase over time. As long as we don't spend it, the money in our savings account is going to continue to go up. But in our second example, right here, we can see that the money in our account is decreasing, and eventually we're going to hit an amount of $0. So our x-intercept in this problem, this is our x-intercept. It is going to represent the amount of time that it takes to hit a y value of 0. This is amount of time it takes for our account to have $0 in it, okay? That's the amount of time it takes in weeks for our account to have $0 in it. So I just wanted to show you guys some examples of what our graphs could look like when we're talking about word problems. So let's move on and look at actual word problems, okay? So let's look at this first example. I have here a graph for you guys. This is compliments of Miss Andreessen. She put this together for us. We have this graph right here. We can see our y-intercept is at -4. I can't really tell where our x-intercept is right now, but I can tell that I have another point, a good, nice point that I can use to find slope right about here, okay? So I can use this graph to count our slope. 1, 2, 3, 4, 5, 6. Our rise was a +6, and our run was 2. Rise over run, y over x, the change in y over the change in x. So we know our slope was 6/2, which of course can be reduced to 3. And we see that right here in our slope. We also see, we've already talked about this, our y-intercept is right there at -4. That's why the -4 comes into play. We have an equation here that's always in y equals mx plus b form. That's something that we've already talked about. And these 2 points right here are just ordered pairs that are represented on our graph. So I have a point at 0, -4, we already found, that's our y-intercept. And we have a point at -1, -7, -1, -7. That's another point that we could have used to count our slope. And then, of course, a table of values just consists of any points that we could find that fall on our graph line, okay? The verbal description here would be a function is increasing with a slope of 3 and has a y-intercept at 0, -4. So let's look at an actual word problem. It says initially, there's a key word already, Initially, that's our beginning or our start value, the outdoor temperature was 35 degrees Fahrenheit. So when time is 0, our temperature in degrees Fahrenheit was 35 degrees. So let's go ahead and plot that point on our graph. We have a point at 0, 35. This is our y-intercept. Time is 0. Our degrees Fahrenheit is 35. We should probably label our axes too. So this is time. And our y-axis is degrees Fahrenheit. Okay, and then it says 10 hours later, the temperature increased to 55 degrees Fahrenheit. So 10 hours later. So on our x-axis, I'm going to go ahead and put hours down here too, so we know how much time has passed. It's not just minutes or maybe even days. But after 10 hours, our temperature increases to 55 degrees Fahrenheit. So we have these 2 points on our graph, okay? So we could create a table of values if we wanted to. Our initial value was 0.35, and then we had another point at 10.55, okay? Now again, we can always count our slope if we wanted to. Let's go ahead and put our ordered pairs here. We can count our slope if we wanted to, or we can use our slope formula. So let's practice using our slope formula since we've obviously already counted on the graph with our first problem. So remember our slope formula. Let's use blue. So m equals y2 minus y1 over x2 minus x1. And I would encourage you to always label your points. So if this is our x1 value, this has to be labeled y1. And if this is x2, this has to be labeled, y2. Remember, every single point has one x and one y value. So let's substitute in our values, okay? Our y2 value was 55. Our y1 value was 35, so 55 minus 35 over. And then our x2 value was 10. Our x1 value is 0, so 10 minus 0. 55 minus 35, that gives us 20. And then 10 minus 0 is, of course, 10. So we know our slope value, 20 divided by 10, is just 2. We also know that our initial value, that's our b value, was 35. So we can write this equation in y equals mx plus b form. So this is just y equals, the slope we found was 2, and then we always have our x variable next to slope, and our b value was 35. So y equals 2x plus 35. All right, let's look at one more example. Mr. E filled up his car with gas. He had to pay $3 per gallon. He already has 2 gallons of gas in his car's tank. So we're going to talk about money and we're going to talk about gas, okay? We're going to talk about money and gas. So this is dollars and gallons of gas. Okay, so he starts out, he has to spend $0 and he already has 2 gallons of gas in his car. So when he spends $0, he's got 2 gallons of gas. Now, if he purchases 1 gallon of gas, he spends $3, right? So $3 is on our x-axis. So I'm going to go to the right 3, and that gives us, or that gives him 1 more gallon of gas. So we're going to go ahead and plot another point here. $3 gets him up to 3 gallons of gas. Well, if he spends $3 more, that gets him up to 4 gallons of gas. Okay, so let's plot another point. $3 more is another gallon of gas. So this right here could represent the situation with money and gallons of gas in his car. Okay, so we could make a table of values using the points that we just found. So here's x and here's y. Remember our initial value, when he spends $0, he's got 2 gallons of gas. $3 is 3 gallons of gas. $6 is 4 gallons of gas. Okay? In this case, if you want to list your points out, you definitely can. These are all ordered pairs, 0, 2, 3, 3, 6, 4. Now let's talk about our rate of change, and we'll go ahead and we'll use our graph here. It's very important that you're always paying attention to how large each square value is worth, right? So in this problem, each square is only worth 1 unit. So every time we rise 1, we run 1, 2, 3. It's our rise over our run. Rise, positive 1, run 1, 2, 3. So in this problem, our slope is rise over run, 1 over 3. Now again, what does 1 represent? 1 gallon of gas. And what does our 3 represent? $3. Let me go ahead and scoot this over a little bit and put a dollar sign here. So that's our slope. For every 1 gallon of gas, he pays an extra $3, right? So how do we write this as an equation? Here's our equation. Y equals mx plus b. I know my slope is 1/3. I know my x value always gets multiplied by my slope. And then my b value is just our initial value or our y-intercept. And in this problem, it's worth 2. So y equals 1/3 x plus 2. And that's how you can use all of the information so far that we've gone over in class to talk about word problems, to talk about their initial values, all that good stuff.